Hello, welcome back. So here we go. Let's talk about the code that's going to make this thing go. And what you should do or should realize is that basically what I did was simply take the code that was the turn signals and modify it a little bit. So when you see this, you're going to see a lot of similarities, things you should be becoming familiar with. So for example, down here, this loop where we had the and, you know, the logical level, it better be true. All this is identical, didn't change a thing. All this, identical, didn't change a thing. What I did change, and actually I just realized this, I can delete this because I'm not going to use my little delay subroutine. We're just going to get rid of it. Okay, still have my two booleans, which are switch 1 and switch 2, which correspond to the feelers that we have built on this robot. And I think you can almost see it, okay, and I'll turn it on in a moment. If neither of these switches are engaged, okay, that is this parameter here, all right, in which case the pull-up resistor is going directly to pins, what were they, 10 and 11, all right? It's going straight there. Both of these pins are high. And it's saying, yeah, that one's high and that one's high. All right, well, that means the switches are off. What do? Well, we simply output this simple little bit. Remember, this bit and this bit, these two lowest ones, are set up on port D for transmit and receive. And then we have a 1, 0, 0, 1. Okay? This first 1, 0 corresponds to one side of the L293 chip. Okay? The second one corresponds to the other side of the L293 chip. So when we're looking at it, I can pull that back just a little bit. Here, pull it in so we can see that more. There we are. So what that means is it's sending a high and a low and a low and a high to these input pins. Okay, the chip is already enabled here and here, so therefore the motor is going to receive signals corresponding to these two highs. Now, what did I do? Well, you know, did I really know what was going on? No. You know what I did? I set that up in a way that made good logical sense when I see it. All right. I like 1, 0, 0, 1. When I got it going, originally this wheel spun the wrong direction. Well, what did I do? Well, I unplugged these two wires and flipped them because I want both of these wheels spinning so that the robot goes forward. And now I know every time I see these lights light up and this signal, that means go forward. All right, reverse, you can imagine, is pretty much the opposite of this. And here you can see it, 0, 1, 1, 0 for those 4 bits, which are regulating the L293D. So let's look at it. If a switch gets set, all right, and it goes low, it grounds, it means it jumps up to one of these subroutines. They're both pretty similar, well, very similar. What does it do? Okay, well, first thing it does, it throws the robot in reverse. And then it, for 3/4 of a second, 750 milliseconds. And then ever so briefly, this is an old habit, just trying to ground the system out, I give it 5 milliseconds of a dead stop, just to make sure there's no residual current. I don't like this flipping H-bridges or the L293s switching direction, because remember, a motor is a generator in reverse, so I don't want to feed back anything. So I give it 5 milliseconds to chill out. And then notice here we got a 1, let's see, what do we got here? We got a 0, 1, 0, 1. Slightly different than the 1, 0, 0, 1 going forward. One wheel is going to go forward, one is going to go in reverse. And again, I do the same thing, a brief chill out period. If the other switch is flipped, once again, I throw it in reverse for 3/4 of a second. All right. I give it a brief chill out. May or may not be necessary. You can play with your robot. 5 milliseconds, I think, is time well spent. And then it flips it. Notice? Okay, in this case, it's 1, 0, 1, 0. So one wheel is going to go forward, one is going to go in reverse. It's going to cause the robot to turn. Chills out briefly, and then it continues on with the loop. And if there's neither feeler is hit, well, then it just rolls on. So let me plug it in, and we're going to watch it go. All right. So I think you can see, although the video makes it look kind of funny, it is going forward. And if I hit this sensor, watch the lights and the wheels. Okay, do you see that? Reverse, turn, forward. Reverse, turn, forward. If I hold it, reverse, turn, forward, reverse, it'll just get stuck in that loop and eventually get itself out. If I go this way, okay, works beautifully, right? Now ultimately what we're going to want to do is we're going to want this thing running completely autonomously. Notice I have the 9-volt supply. This wire, it goes to ground. This one looks like it's hooked up to something, but actually this first row is not connected to anything. It's a good place for me to set the wire. So now I'm going to move the 9-volt and turn it on. And now it's running autonomously on a 9-volt supply. And it works the exact same way. So I'll probably shoot a little video of it running on the floor and put it all together. And I'll see you on the next video when we start talking about analog sensors. See ya!